All right, folks, I need you to set up your notes just like you see them on the screen right there, like we always do. Put the video on pause and set them up. All right, thanks for doing that. Look, we're going to talk about these top two functions today. We're not going to talk about the bottom two today. We'll talk about those tomorrow. So what I want you to do in your notes is put a little dash line going through here like this. And why don't you put down Wednesday? This is going to be what we do today. Today's the 14th, right? So 1/14, and then this is what we're going to do tomorrow. Okay, so that'll be on 1/15. All right, now that we're organized, why would I break it up like that? Well, what do you notice about these two solids? And first of all, like, it might not make sense in my drawing, so let me show you an example. Last night I was having some crackers, and I was eating it with some avocado. I mean, usually you have avocado, like guacamole with chips, with tortilla chips, but I ran out of chips, so my wife handed me this box. True story. Not that you care. But hey, look, this is a rectangular prism. Okay, so that's what they call these things right here. These are prisms when you have a polygon for a base. So this is like one of my bases here, right? And then this is, you'd probably call it the bottom of the box. So there's two bases, one here and one here, and it's sometimes called a box, but mathematicians call them prisms. So I want you to put that right here, prism. Now, what's an example of a cylinder? Well, one of my favorite cereals to eat is Quaker Oats. I put a bunch of sugar in it, or maple syrup, and maybe some cinnamon and raisins. Oh my gosh, it's making me hungry right now. Now, this box is obviously not the same as this box, right? This one has a polygon for a base, and this one has a circle for a base. And you might notice this one's kind of cut down the side, and the top, the lid. I think a lot of times these lids are red. I don't know why I feel that way, but the lid is missing and the base is missing. Now, I do have the base. Here's the base. The shape of the base is a circle, right? And it would go, right on here. And you can see there's like this extra layer, probably because it used to fit up in there and they glued it onto the bottom of the box, right? So, okay, let's put that down right underneath the cylinder. And I think my question was, why are we talking about these two today and these two tomorrow? Well, what do you notice between these two? What do they have in common? And how are they different from these guys down here? Well, these guys only have one base, and these guys have two bases. So let's make a little note of that. This is a base up here, right? But there's also a base on the bottom. So there's two bases, right? Base is up here and the base down there, and they're identical to each other. It's like this base right here just slides all the way through the object, and then it becomes the top base if you wanted to imagine it that way, right? Okay, well, look, we're going to talk about area of these things. Why is area important? Well, they need to know how much material is, making these four sides, and then how much material to make the top and the bottom, the two bases. Okay, so if we're talking about total area, sometimes they call that surface area. If they talk about just the sides, they call it lateral area. Okay, so let's put that down somewhere, maybe off here to the side. The lateral area is the four sides, and the surface area, oh boy, surface area is the lateral area plus the bases. Surface area equals I'm going to call it LA for short. This right up here, LA. Would you put that down in your notes for lateral area? So I'm going to take lateral area plus two bases. Okay, well, let's just talk in general for a second. The base of this guy is a circle, so why don't we put down pi r squared, right? We're talking area here. And the base of this one happens to be, I guess, I mean, you could think about it as like a rectangle. In my drawing, it looks like a square. But guys, it could be any shape. It could be, oh, let me go grab one. Hold on one sec here. Hold on, let me show you one. It could be a octagon for a base. See? That's an octagon, I think, right there. So this is a prism, and the bases happen to be a polygon that's not what you would expect. You know, like if you're thinking about a box, I don't know if you see too many. Ooh, there's like a chocolate out there. I think Toblerone chocolate puts their chocolate inside a box that kind of looks like this, but they kind of sit it on its side, right? So, all right. Whew, I'm kind of getting ahead of myself, excited about this. How about we talk about the cylinder first, okay? So look, if we wanted the lateral area, couldn't I take the box, like I've already done, and cut it down the side, and then I could open it up. And if I open it up straight, as flat as possible, let's see if you can see that. Hopefully you can see that shape. That would be a rectangle. Let me turn it this way so that the decorations aren't distracting. Do you see how that's just a basic old rectangle right there? Right? Okay, so how are we going to find the area of this rectangle? Well, we need to know what the height of the rectangle is, and we need to know what the base of the rectangle is, or the width of the rectangle, right? So the height of the rectangle over here, and then the top part of the rectangle, which would be the whatever you want to call it, the width or the base. So when I roll this up, notice this. The circumference of the circle is that top dimension. It's that top dimension. You maybe can see there's like a piece of plastic on here. So if I could stretch that out nice and straight, that dimension right there is the circumference, okay? So what we want is the circumference of this circle. Let me put it in red so it stands out. Boy, I hope this is red right here. Yes, all right. So that right there is the circumference, right? And then what we need to do is take that circumference, right? I'm taking that circumference, and I'm going to multiply it by, I need like another hand here to hold this open. It wants to roll back up. I want to multiply by the height. Hopefully you could hear me over there. I was behind the box. So I'm going to take the circumference times the height. All right, so let's put that out to the side here. That's called the lateral area. Oh, geez, I got to move my stuff over here. Oh, shoot, it didn't let me do it. Hold on. Patience, please. Thank you very much. So let's move this guy over. So look, the lateral area doesn't have four sides if it is a cylinder. So maybe this is a bit of misleading information, right? So what I'm going to do is I'm going to erase that four side stuff. Sure, it has four sides if you had a box, you know, like this box right here has four sides, a front and a back, and then the sides where they put the nutritional information, right, or a little bit more advertising. But if it's a cylinder, man, it doesn't have four sides. It has just one whole flat, kind of, well, not flat, but curving surface, right? So let's do this. Let's just put a formula out there. And the good news is the formula is the same. Oh, no. The formula is the same whether you're dealing with a cylinder or you're dealing with a box or a octagonal prism. It doesn't matter. That's the good news. We're going to take the perimeter of the base and we're going to multiply it by the height. Sorry that this is taking me a little bit. Perimeter times the height. Now, will the perimeter formula change depending on what the shape of our base is? Yes. If it's a cylinder, like this one right here, the lateral area, oh, geez, I wish I was more organized. The lateral area is going to be, it's still perimeter times height, but it's the circumference. Okay, so circumference is pi times diameter times the height. Okay, I want you to think about it in your head. Why am I putting pi times diameter there? Because that is the perimeter of the base. That's what P stands for, perimeter of the base. Okay, so let's make a note of that. That's the perimeter of the base. Okay, now I know I forgot the word of in there. But will it matter if the base has, 4 sides or 6 sides or 10 sides or whatever? Well, it does matter, because you'll add up, like if you had more than 4 sides, you'll add up 6 sides or 10 sides. Like this one right here has 8 sides for its base. So you're going to get the perimeter of the base, and then you're going to multiply it by the height. Guys, that's just the sides. Can you imagine you go to the store and you pick up a box of oatmeal? If your hand's big enough, you just grab it. You grab it right by the lateral area and you pull it off the shelf. If your hands aren't big enough, I guess you got to use maybe 2 hands, and you go like this and pull it off the shelf. Or you go from the bases and you pull it off the shelf. But if you grab the sides, that's called the lateral area. All right? So that's how you get the lateral area. And then to get the whole surface area, we got to add the bases in, right? So I like my formula right here. I take the lateral area plus 2 bases. Okay, well, let's try this right now with the cylinder, okay? If I measure the cylinder right here, let's say it's 8 inches, okay? So I put over here 8 inches, 8 inches. Would you do that for me? And then if I measure the radius, so the radius would go from the center out to the edge, right? So from the center out to the edge, I could measure the diameter, go all the way across the thing, and then cut that in half, of course, right? So the diameter is 4 inches. I measured the diameter, comes out to be 4 inches. So let's put that over the top of our figure, and I'm going to zoom in on that figure, okay? So give me 1 second here. Okay, so we're going to put 4 inches across the top, so let's do that right now. There's 4 inches going from the left side to the right side. All right, so let's figure out the circumference right now. The circumference would be pi times 4 inches, because it's pi times diameter, right? So usually we put the number in front of the pi, so I'm gonna put 4 pi down. So that's the circumference. That's this distance right here, all the way around, okay? And then what I'm gonna do is I'm gonna multiply that by 8. So my lateral area is coming out to be, 4 pi times 8, which comes out to be 32 pi. And this is in inches, and it's area, so I'm going to go square inches, right? How many squares would fit on the sides of this object? Now for surface area, we've got to add the bases in. So I go 32 pi plus, let's see, how do I get the area of the base? Well, that's where we need the radius. The radius comes out to be 2. And I really wish I would have picked a different number than 4, because the area of the base is going to look identical to the circumference. But the circumference is just in inches, and the area is going to be in square inches. So the area formula, remember, for a circle is pi r squared. And then I go pi times 2 squared, and I end up with 4 pi. Why do I want that? Well, that's one of these bases, and there's 2 of them. There's a base on the top, and there's a base on the bottom. So if I want the surface area, and I'm going to put some units on this, maybe this will make things a little bit clearer. So it's 4 pi square inches. Notice the circumference was 4 pi inches. Dang it, I wish I would have picked a different number than 4, or a different cylinder here. So if I want the surface area, I got to take 32 pi, that's the lateral area, and I'm going to add 2 bases. So I'm going to add 2 4 pi's to my 32 pi. So let's see, what does that come out to be? 32 pi plus 8 pi. That comes out to be 40 pi square inches, okay? So we just did a lateral area and a surface area. Now, here's what I'm going to do. I'm going to pause the video, stop it completely, and I want you to go find a homework problem. I want you to try these 2 formulas out. I want you to try the lateral area formula out and the surface area formula out, and then I'm going to come back and I'm going to try problem number 1 from the homework with you, and then I'll try another problem with you to help you a little bit. All right? So open up the assignment, try problem 1, see if you can figure it out based on these 2 formulas that I just gave you. Thanks for watching.